In part 3 of this episode, let's talk about how we divide polynomials. So previously we were dividing single terms by other single terms. But remember that a polynomial refers to multiple terms added or subtracted. So if I have multiple terms added or subtracted, and I divide that by something like x to the power 71, how would I go about that process? So for an example, for a real world example, suppose that I had me and my friend Allison and my friend Sarah, and we have our leftover Halloween candy, and we're bringing it together. We're making one big pile out of the Halloween candy, and then we're splitting the candy evenly between the three of us. Now, my favorite candy are Twix bars, so I'm going to bring Twix bars to the pile, some unknown quantity. Allison is going to bring Reese's cups. We don't know how many. We're just going to call it Y. And Sarah is going to bring red vines. We don't know how many, so we're just going to call it Z, a variable representing that unknown number. If this is what we're planning to do, let's write down an expression that represents the candy that each person will receive. Now, one way to think about the process I would use to pool our candy and then split up the candy this way is Sam and Allison and Sarah all put their candy together into one big pile and combine the candy as x plus y plus c, this big candy pile, this big sum of all the individual candies that everyone has brought. And then after our candy has been pooled together into one big pile, we just go into that pile and divide up the pile evenly into three portions. Now, another way to divide the candy evenly is that instead of throwing all the candy into one big pile and then redistributing it and dividing it by three, Sam can come in and she can divide up her pile of Twix bars among all three of the people. Allison can divide her pile of Reese's cups among the people. Sarah can divide her red vines among the people. And then each person will end up with the combined total of the Twix bars they got from Sam, the portion of the Reese's cups they got from Allison, and the portions of the red vines that they got from Sarah. So, in other words, dividing the entire quantity, x plus y plus z by 3, is equivalent to if you just divided x by 3, y by 3, and z by 3, and then just added those results. This idea of being able to divide a polynomial by dividing each term individually is what we are going to be using in this part of the episode. For example, if someone says to me, simplify 4x plus 6y all over 2. What I'm going to do to simplify this expression is I'm going to split up this numerator, and I'm going to split it as 4x over 2 and separately 6y over 2. Now, all I have to do is simplify each of these individual fractions one by one. Now, 4 in the 4x over 2, 4 is the same thing as 2 times 2. 6 is the same thing as 3 times 2. So in each of those fractions, if I cancel out this 2 that is both multiplied and divided, then looking at what I have left behind, I have 2x in this first term, 3y in this second term. 2x plus 3y would be the simplified version of this fraction. And to get that, all I did was divide each term in the numerator by 2, one at a time. Let's try it again. Suppose I had 6x squared minus 8x plus 2, and I wanted to divide that whole quantity by 2. Once again, I can just go ahead and divide each term by 2 separately. Now, 6 is the same thing as 3 times 2. And if I cancel those common 2's, I'm left with just 3 here. 8 is the same thing as 2 times 4. If I cancel those common 2's, I'm left with just 4. And 2 divided by itself results in just 1. So I have 3x squared minus 4x plus 1. That would be the result of dividing this polynomial by 2. Someone says, I want to simplify 3x squared plus 6x by 3x. To do this, I'm just going to go in and divide each of the terms in the numerator by 3x separately. Now, if I simplify this first fraction, here I have 3xx in the numerator, 3x in the denominator, and on the side I have 3 times 2 times x divided by 3x. And in the first fraction, if I cancel the common 3's and the common x's, and in the second fraction, if I cancel the common 3's and the common x's, I'm left with x in the first term and 2 in the second term. So here I have x plus 2. So this is how we divide polynomials by terms. We just divide the polynomial one piece at a time.